Okay, someone had asked for help on doing the stoichiometry assignment, so let me try see if this would help. So for 3.5 stoichiometry, we have these rules for conversion, which I'm going to be using these rules right here. I mean, you have other rules that other teachers would use as well, but I like my own rules. So first thing is answer two questions. Are you dealing with two chemicals? If you are, then you need a balanced equation. If you are dealing with grams, then you'll need to get a periodic table to find the molar mass for that chemical. So once you answer those two questions, then you do the steps. Start with the number that's given in the question, whatever you're given in the question, and then multiply by your conversion fractions. The number of fractions you'll be using was based on those two questions earlier. And remember, what you want to find always goes on top. So the questions, whatever it's asking, goes on top. And then whatever you started with goes on the bottom. And then you just do the math at the end. So we'll follow these rules here. So let's go ahead and do a quick review, and I don't know why that's there. So here's a quick review. Here's a question: how many grams is in 3.4 moles of oxygen? I only have one chemical, which is oxygen, and my question is asking for grams. So since I have grams here, I do need to find the weight, the molar mass of that chemical. So molar mass of your chemical, which in this case is oxygen. So I will be more specific in future questions, but usually when chemists talk about oxygen, they're asking about the oxygen molecule. So I'm going to find the weight of two oxygen atoms combined together to make one oxygen molecule. And to do that, you go find a periodic table, find oxygen right here. Oxygen is 15.999 grams per mole is the weight. We'll round that to 16. Or actually, I guess we'll just keep it at 15.999 so you don't get confused. 15.999. There's two of them, so multiply this number by 2. So you would get a total answer, and I'm going to grab a calculator here, 15.999 times 2. I have 31.998, but I'll just round that to 32. We're rounding to 2 decimal places, so that would push this 8 to a 0032. Okay, so this would be 32 grams per mole when you round it. This is the molar mass of oxygen. The mass of 1 mole is what that means. All right, so we've answered our 2 questions, and now we can do our setup steps. So you start with the number given in the problem, which is 3.4. 3.4 what? This is 3.4 moles. And the chemical is oxygen. Since we are dealing with one chemical, this was kind of unnecessary, but I'll do it anyway. Now that we have what I started with, now we're going to multiply this by a fraction, and we only need one fraction, the molar mass fraction. So what goes on top and what goes on the bottom? What I want to find goes on top. So how many grams? Grams goes on top. So I want to figure out how many grams of oxygen this will be. So the mass of oxygen, so for 1 mole, the molar mass of oxygen is going to be 32 grams per mole. Again, I got this. This is your molar mass fraction. So I'm just plugging in whatever I found here, right here. I'll use a different color, or yeah, let's go with that color. So I'm taking this number I found earlier and plugging it in into this fraction. So when you do the math, this is 3.4 times the top numbers divided by the bottom numbers. Since it's a 1, there's no point dividing by 1. 3.4 times 32 is, I guess I could just multiply this by 3.4. 108.79. Or as long as you have something around that number, you're good. So 108.8, or if you round it to 109, it should still be fine. Moles of oxygen can cancel, so that means yes, I did set this up correctly. My final answer is grams of oxygen. Okay. So this is actually a reminder from 3.3. This was assignment 3.3 where we dealt with molar mass. So let me go ahead and skip to a 3.4 question or 3.5 question. We'll just practice around. Okay, again, we're just using the exact same steps all the way. So let's look at our question. How many moles of oxygen will react with 5 grams of iron? Okay, every single time you're going to figure out what am I looking for and what do I start with. These are two pieces of information you'll need to find for every single question. You're dealing with two chemicals, so I need to balance this equation. I will probably give you a balanced equation for the most part, but if not, know how to balance equations. So when balancing, always start with whatever's not balanced. So nothing is balanced here. I have 1 iron on this side, I have 2 irons on this side, 2 oxygens on this side, 3 oxygens on this side. Iron is all by itself. That's the easiest way to balance. All I need to do is put 1 number here. Let's balance oxygen first. I have 2 on this side, 3 on this side. So if I put 3 oxygen molecules and 2 iron 3 oxide molecules here, this is iron 3 oxide if you don't remember the name. This will balance my oxygens. 3 times 2 is 6 oxygens. 2 times 3 is also 6 oxygens. Remember these numbers? Whatever number I put here multiplies the numbers in the formula. It's those subscripts. Okay, so that's 2 times 2 gives me 4 irons, so this has to be 4. Okay, I have grams here. So my second question was asking if I have grams, I need to find the weight of iron. So going to my periodic table, iron is right here, 55.845. This is just pure iron, this thing right here, so that's just 55.845 grams per mole. That's iron. All right, so now that I've answered my 2 questions, now we can set up our thing. Start with what you're given, which is 5 grams of iron. I'm going to have 1 fraction here, and I'm going to have 1 fraction using this. So I'm going to multiply this by 2 fractions. Now before I move on, let me double check with you. You only use numbers once. So this 5 grams of iron, it's already written right here. I cannot use that number anymore. Whatever numbers I use will either be from the molar mass or from this equation. So let's go ahead and go in order. Here's the molar mass. We'll put the molar mass in this fraction. We'll put the equation in this fraction. So the thing you need to figure out is what goes on top and what goes on the bottom. What I want to find goes on top. I want to find moles, so I cannot put grams on top. So moles needs to go on top. And so this is grams per mole, and this is for iron. Remember, this molar mass is for iron. Okay, and then 55.845, this number is 55.845 grams per 1 mole. So this is 1, and this is 55.845. Okay, so we are done with that fraction. In this fraction, this equation is called a mole ratio. Mole ratio means I'm comparing 2 chemicals together. So this was from 3.4 when we dealt with mole ratios. I skipped an example of that because I felt like we should just, if you need more examples, let me know. But mole ratio is where you have moles over moles. You just need to figure out which chemical goes on top and which chemical goes on the bottom. The chemical I'm looking for is how many moles of oxygen. So oxygen goes on top. The chemical I started with, iron, goes on the bottom. Okay, so this is where you kind of have to remember how to name your chemicals. This is oxygen, this is iron oxide. Technically it's iron 3 oxide because there's more than 1 version of iron, but I'll probably let you know, you'll probably see it in the questions. In any case, so now what numbers do we use here? Well, oxygen, we're going to use 3. Iron, we'll use 4. So mole ratio is using the numbers. I'll highlight them if you do not see it. We're using these numbers that we use for balancing. Okay, we don't care about the subscripts. That's a part of the formula. It's a part of the chemical. We want to know how many molecules, how many chemicals were used in this equation. Okay, now I've finished setting up my fractions, so now I just need to do the math. 5 times 1 times 3, divide by 55.845, divide by 4. Bottom numbers are division. So let's put that in a calculator, and hopefully you can see my calculator here. So it's 5 times 1, which is just 5, times 3, divide by 55.845, divide by 4. So your answer should be 0.067. We'll just keep it to 2 numbers. So this is 0.067. Double check that I wrote that correctly. Yeah, 0.067. Let's see, grams cancel, moles cancel. This is moles of oxygen, which is, yes, what my question was asking for. This canceling part is really just to double check that, yes, I did this correctly. All right, so that is one example you might see in 3.5. Let's see, we should have a grams to grams problem. Let's do this one. So notice that I just recycled the same equation. Let's see, oxygen, and this is 3, and this is 2, because I am dealing with iron and oxygen, 2 different chemicals. And then this is 2 times 2 is 4. So here's my balanced equation. I need to find grams of iron. So I need this molar mass, and I also need grams of oxygen. So I also need the molar mass of this right here. I don't know why I highlighted the 26 as well. We'll use this one later. So before we set up our problem, let's go ahead and find the molar mass of iron. And we'll also need the molar mass of oxygen. So going back to the previous problem, notice I only needed the molar mass of iron because this was grams of iron. I did not need grams of oxygen. But in this one, since I have grams of both, you do need to find the mass of both. Well, at least all the chemicals that are in the question. So that's why I say, that's why one of the questions I put into the notes here is, are you dealing with grams? If you see the word grams, then you need to find the molar mass for that chemical. Okay, so, you know, there's hints to help you figure these out. All right, molar mass of iron is 55.845. So molar mass is just the total weight of that chemical, grams per mole. Now, if I had asked for the molar mass of this chemical, you do need to have the weight of 2 irons and 3 oxygens. So do remember it's a total weight. When I created these questions, I decided to be lazy and I did not want to do this. So that's why we're just sticking it here. So molar mass of oxygen, this is 2 oxygens. So 1 oxygen is 15.999. But the chemical itself is 2 oxygens. So remember to multiply this by 2. So if it helps, find the number on the periodic table and then multiply by whatever subscripts is in the formula. Okay, so don't forget this part. A lot of students forget to multiply by the numbers in the formula. So you only find like the weight of that one single element, but not the weight of the actual chemical. So do be careful of that. And we did this earlier. This was 32 grams per mole when you put in the calculator. All right, so there is our balanced equation. And then, can't draw circles. And then we have our molar masses for both chemicals. So when we go through our steps, first step, start with the number in the question, which is 26 grams of oxygen. Always label your numbers so you can keep track of which number you should multiply and divide. We're going to be multiplying by 1, 2, 3 fractions. We want a balanced equation fraction, a molar mass of iron fraction, and a molar mass of oxygen fraction. So we're going to have these 3 fractions. The order doesn't matter. You could go in whatever order you prefer. I like to since the order doesn't matter, I just go in the order of, okay, I want to make sure the labels cancel so I don't forget anything. This is grams of oxygen, so I'm going to put grams of oxygen here. The only one of these three fractions that is dealing with grams of oxygen is this one right here, the 32 grams per mole of oxygen. So remember, 32 goes with grams, so the other part is mole, 1 mole of oxygen. Okay, so this is my molar mass of oxygen. Molar mass of oxygen. All right, the next step, this is moles of oxygen, so I'll just go ahead and put moles of oxygen here, just to, cancel them in order. The only one that of these two fractions that are left, this is molar mass of iron, so has nothing to do with oxygen. So I'm going to be using this one here. I have 3 moles of oxygen. I just need to figure out what is the moles of the other chemical. What chemical am I looking for? Grams of iron, so I'm looking for iron. Iron needs to go up here. Okay, so that would be 4. Remember, this is the mole ratio. Mole ratio. The mole ratio between your balanced equation, where the chemical you're looking for goes on top, and the chemical you started with, which is oxygen, goes on the bottom. Final fraction is the molar mass of iron fraction. So here, I'm just labeling it just because. Molar mass of iron. Okay, so what goes on top and what goes on the bottom? Is it grams or moles? What I'm looking for goes on top. I'm looking for grams, so grams goes on top. You could have also said, well, I have moles of iron here, so this must be moles of iron down here. And again, the only thing that deals with moles of iron, aside from the equation, is the molar mass. So remember, molar mass is 55.845 grams per 1 mole. Okay, now need to put this in a calculator because we already filled in all our numbers. So remember, top numbers go on are multiplied. Sorry if you can't see my calculator here. I'm trying to fit it within the screen. Let's see if I can make it smaller. I guess that works. Okay, top numbers go on the top, bottom numbers are division. Let me turn off my phone. There we go. I'm back. Okay, what were we doing? 26. Start with the number you're given. Divide by 32. Times 4. Divide by 3. So divide by 3. Times 55.845. Notice I skipped the ones because multiplying by 1 and dividing by 1 does not change your answer. So why am I wasting that time writing that down? So my final answer is 60.498, which rounds to 60.5. So this final answer is 60.5. Moles of iron cancel, moles of oxygen cancel, grams of oxygen cancel. So your final answer is grams of iron. Again, this is just a way to check to make sure you got the correct question answered. It's not necessary, but it's useful when you have like a really long equation. Okay, so with that, hopefully it was helpful. It was a good review, maybe. Let me know if you need more help.